Have you ever gotten lost on Swinburne campus? Do you find it difficult to locate your classrooms among the buildings? Have you ever felt that something about the campus layout is confusing? Our wayfinding solution is designed to make navigation easier and improve your campus experience.
SVG/ISOVIST for the site prior to any changes being made. Lots of blue can be seen on the diagram, and this blue represents low visual connectivity, which is something we aim to improve on. One precedent that inspired our main method of improving wayfinding on campus was inspired by Baron von Haussmann's city surgery in Paris, where a series of axes were cut into the existing city, with landmarks being placed in the centre or at the ends of each axis, as highlighted here in this diagram. This was to help improve wayfinding within the city and help people locate where they were, regardless of what axis. This diagram briefly shows some of the strategies we employed to help improve wayfinding on campus, where the red represents areas we cut through buildings or demolished buildings, and the dotted line represents where we push back some landscaping to help improve visual connectivity, and the black lines show the 4 axes that we have now created for the campus, with the John Street axis being the pre-existing one and the other 3 being the new axes that we have created. This ISOVIST looks at the visual connectivity after we implemented our proposed changes to campus, being the cutting of existing buildings to create new axes, the rounding of certain corners and pushing back of some landscaping to help improve visual connectivity. And you can see that a lot of the dark blue has been eliminated, especially in comparison to the original ISOVIST, and a lot of it's been replaced with a lighter blue turquoise. In terms of the learning circle, even green and yellow, which shows that the visual connectivity and wayfinding on campus should be greatly improved.
As you can see, the first VGA diagram shows the new connectivity formed after the pathway intervention, with the white line indicating the proposed road. All the blue buildings are proposed for demolition. The second VGA diagram illustrated the newly defined facade, which becomes the most connected space after the pathway intervention. The white line indicates the most visible facade. This diagram shows the buildings we identified on the Swinburne campus in a 3D model created using 3D Max. It helps us explore different iterations of the facade and building form. This animation shows the facade iteration created using Tyflow, helping us visualize and think in 3D.
The first diagram shows the light study conducted across the Swinburne campus. The color scale below represents levels of visibility, with blue indicating areas that are least lit or least visible, while yellow or red shows higher illumination and stronger visual exposure. By placing a light source where each landmark is proposed, I was able to test how far the light would travel and stay visible across different parts of campus. The perspective view helps visualize how building heights and massing affect the spread of visibility. You can see how certain corridors and open nodes capture more light, shown by the yellow and red zones. These areas become ideal for landmark placement, as they are easily seen from multiple directions and distances. In this view, the transition from red to blue areas shows how the landmark's visibility gradually fades. This helped identify how each proposed point connects to the next, ensuring that as someone moves through the campus, one landmark remains visible before the next appears, creating a continuous sense of orientation. Here you can clearly see how the red zones align with the key intersections and gathering points. According to Turin and Mayer, successful wayfinding relies on structure and differentiation, giving people visual cues that help them recognize where they are and where to go next. These high visibility zones, therefore, act as natural anchors that structure movement across campus. This final render shows a more realistic visual of how the proposed landmarks might appear in low light conditions. The simulation reinforces that the most visible or red highlighted areas correspond to key campus nodes where a landmark would have the greatest impact. Ultimately, the study ensures that landmarks are not just aesthetically placed, but strategically proposed to enhance clarity, orientation, and overall legibility within the university.
For this iteration of facades, we chose to feature the likeliness of 3 people significant to Swinburne, with these 3 being our current Chancellor Professor John Pollers, current Vice Chancellor Professor Pascal Cresta, and one of Swinburne's founders, George Swinburne. Our proposed design for the BA building features the Vice Chancellor's face depicted with a dot design. Her face is also used in the area where we cut through the AD building. We've also placed the Chancellor along the GS building using a stripe design so that he can watch over our new northwest axis. The chosen facade for the TAFE building uses pillars at different spaces to emphasise the axis intersection in our new campus design. Our final featured facade pays homage to George Swinburne and is placed so it's easily visible from the train line running through the campus and will be one of the first impressions people get when arriving from the train station. We believe this design will make the campus more memorable and distinct, as the facade will make the campus easy to remember for any visitors, even if they'd rather forget.